what are we going to talk today about? First, we're going to do a little bit of networking. Sorry, not right now. You can do that later in the afternoon. This kind of networking, more on a technical level. We're going to talk a little bit about how we get traffic into the cluster. So we had from Raphael before already mentioned Ingress and all that stuff. So this is what's going on. I mean, once you wanted to do that in the early times of Kubernetes, you had your node ports, etc., your high ports, you had to manage that. Then you had, from the managed Kubernetes systems, you had the load balancers, pretty expensive. And then all of a sudden we had Ingress. So the easy way to take traffic into the cluster. Now terminology is a bit important here, because at the beginning I was a little bit astonished about what's not your words, but what's written on the slides. So what is the meaning of Ingress? First, it means it's kind of a function. And I'd say it's the act of entering into a room or into bringing traffic into the cluster. That is really the function that we want to have. And the real word for that is Ingress. Fortunately, unfortunately, there was this API, Ingress API, which uses this word perfectly, because this is really the function that we want to have. The problem today is we have a different implementation of that with a different word, and they're not using Ingress again, but I'll get to that. But still we have this Ingress API, which is also part of the Ingress ecosystem. This is the definition. And then we have, obviously, an implementation of that API. There are, again, different ones. The one why I do the talk today is really this one, the Ingress-NGINX implementation of this function of the API. Now, Ingress-NGINX, as it says, is an implementation of that API based on the NGINX product. But it has a few shortcomings. First, the API itself lacks it lacks separation into different types of concerns, areas of concerns. So there are situations where application developers, they roll out a new application, they change an ingress, and it has impacts on other applications if you don't do it correctly. Well, actually, you need to change something, and then you have to coordinate and all that stuff. Also, it is underspecified. It doesn't have all the functionality that it really needed. And you know that, or you experience that in all the annotations that you use with Ingress. And for every different product, for every different implementations, there are different annotations for the same functionality. And that's annotation hell. I mean, I wouldn't want to really use that. Also, and these are the shortcomings of the product itself, of the implementation based on NGINX. We had some recent pretty serious security issues like last summer. And also there is quite a lot of operational burden if you really want to base your production on this kind of product. Obviously there are other implementations which may be better, etc. Anyway, due to this, the Ingress-NGINX implementation is actually retired. I think in the next few days that's going to happen. Retired means there are no more patches. There is no more development on that. Also, well, the Ingress API itself is not deprecated. So it's here, it's within Kubernetes, it is live, you can use it, no problem at all. However, it has a different state. Maybe you recognize it. It's frozen. So that means it's no longer developed. There are no additional features being developed on the Ingress API itself. Okay, what does that mean? I mentioned that already. No more updates, etc., etc. So I would really think about moving away from especially Ingress-NGINX. You can't keep Ingress. that means the way forward, yes, you can use other different implementations of this Ingress API, be that traffic, be that contour, be that HA proxy, whatever you want. This is just another Ingress implementation. It retains the same API. It has probably different annotations. You will need to adapt those. But then you can go on. Not a lot of changes. Personally, and actually from the Kubernetes, well, ecosystem, kubernetes.io, etc., there is a different recommendation, and that means going with what's called Gateway API. This is, from the Kubernetes side, really the successor to the Ingress API. It's this new kind of API. And here the terminology is, I mean, I understand it, but it's really kind of dangerous, because now we are going to talk about Gateway API, API Gateway, Gateway Gateways. Okay. So what is that really? What belongs to this Gateway API? Okay. First thing, we really have a separation into different kinds of concerns. We have a gateway class, and that really defines the implementation itself, the product or the open source project that you're going to use as the implementation for Gateway API. There are differences, like Contour itself, they have an implementation of Gateway API as well, so you can use both of them at the same time. By the way, you can have multiple of these classes within the same cluster, no problem. Then we have the gateway resource. The gateway resource really defines how you bring the traffic into the cluster. It defines the load balancer, it defines the traffic, the proxy instance, etc. And by the way, here on the right side, I mentioned who's basically kind of responsible for that element, for that resource. So for the gateway class, it's really the infrastructure team which builds up the cluster and defines, okay, this is the type of implementation that we're going to use. The cluster operator, for example, Vision, does define the gateway itself. Where is the gateway resource? How many gateway resources do we have? How do we split it into different namespaces? Which application team can make use of which gateway? Which protocols do we run over which gateway? Etc. And then we have what's called the routes, or routes, which really define the traffic rules. So we have an HTTP route, we have a TCP route, we have a UDP route, we have a gRPC route, etc., which really defines how or which gateway receives the traffic from the external world and then handles it and forwards it to the application itself, to the pod. And this resource is really defined by the application team. So they can define that themselves. They don't have to take care of the infrastructure, how that's managed, about how is it exposed to the external side, whether they use a cloud load balancer still in front of it, etc. They don't have to take care of that. All they have to do is define the route from the gateway basically to the application. You attach the route to the gateway and you define the service of your application at the back end. And then there's a fourth element, policies. Not everybody mentions that when they talk about Gateway API. And in the policies, you can define timeouts, for example, manipulations like header manipulations, rewritings, and also security, like filtering, etc., etc. I said here that's the security engineer. It's kind of dangerous to label it that way because this is also part of the application team, really. But it is more like the security people within the DevOps team, or as I call it, the DevSecOps team. So it's really the sec part which handles that, especially if you're talking about security filtering, header manipulation, etc., etc. Because that might need some specific know-how, what you want to do, how you make sure that the traffic still arrives at the application. And that is how it's split up. There are still, within Gateway APIs, some points where there is discussion. For example, the host name can be defined on the gateway and it can be defined on the root, and they have to agree. Well, you can leave it out on one of those, but if you specified it in both, then they have to agree. So there's still some communication going on between the teams, but that's how you do it. And of course, within Kubernetes, this is all defined as a resource, as a manifest. Now, if you want to go that way, if you want to migrate to Gateway API, how would you do that? First, and most important, it is really possible to achieve zero downtime migration. That means your customers won't experience anything when you do that work. And that is because I already kind of mentioned it. Gateway API can coexist. First, different implementations of Gateway API, but also Gateway API can easily coexist with your current solution, like your current Ingress, for example. Whatever product you have behind that. And then Gateway API can be easily operated kind of in cluster, which means it is not exposed to the external side. So the exposure, the real ingress, the function, the act of entering, is done by your existing ingress, for example. But you put the Gateway API, you implement it, you let it run within the cluster, and the ingress, instead of forwarding the traffic to your application service, you point it to the Gateway API service. And then from there, you point the Gateway API, the HTTP route, for example, to your application service, to your pod, well, the service itself. So you can build up this kind of chain. Yes, there is an additional reverse proxy in the chain then, but it really helps you to separate and make it easy for the migration. Because if you go that way, you can really take one service and migrate it to Gateway API without impacting anything else. Well, the important thing here to understand is we're operating on FQDNs. So because basically FQDNs translate to IP addresses, and the Ingress has one IP address and the Gateway API has one IP address. So you cannot mix and match on the same IP address, which basically means you cannot mix and match on the same FQDN. But as long as you can separate those, you can have one part of your application over Ingress and the other one over Gateway API. And that works easily, no problem. And that really helps you because you can migrate one service after the other. Once you've completed, well, no, okay, before you complete, obviously, once you migrate one, test it. Check if the routing is correct. Does it really, the traffic really arrive on your service? And do the policies, do they really work? By the way, testing, having a look at it, etc. Probably most of you know about the headlamp project, a kind of visualization of the cluster where you can look at pods and services and deployments and all that stuff. They also implemented the Gateway API, so you can have a look at all those manifests and you see the routing, what is connected to what, etc. So that really helps understand how the traffic would flow. There might be other projects doing that, but that's the one I know. Okay, so now you have migrated, and then you can remove the old stuff, the old Ingress-NGINX, because kind of you want to get rid of that. Okay, so what you then have is your user trying to access the applications. You have the Gateway API doing the ingress function, and then distributing the traffic to the pods. Now, usually in a Kubernetes cluster, you probably have additional applications, microservices in the backend, which make up your application. And these front-end services try to access you use these services, and obviously then you have kind of traffic going there. this can be, these two gateway APIs, they can be the same implementation, but the same gateway really. If you want to have that, you can separate those. That's really up to how you want to operate all that stuff within your cluster, or how your cluster operator wants to do that. You can obviously have TLS, so encryption on the front. The gateway API handles the certificate rotation. Then you can have TLS encryption in the cluster itself as well. Then the microservices, the applications will need to handle the TLS rotation because yeah, they are the endpoint. Unless, as I said, you are going to use sidecars, etc. Well, don't go there. Okay, this label zero trust. I mean, this is basically the kind of the end. If you have that, it's all done. But there are some advantages with the gateway API that you can achieve. For example, I mean, zero trust is you don't allow access because, for example, this microservice is trying to access that microservice because it's within the same cluster. But you want to make sure that this microservice only accesses this one because it actually received a request originating with the user, which has the right to do that. And so what you can do is, first, you could implement some kind of authentication layer on the first ingress function, the first gateway API, implementing, for example, no IDC RP, so your applications don't need to do that themselves, or they can check tokens, whether they are valid. You can also do that here. So, I mean, everybody uses tokens to access these backend services. So you could implement that function here, and then before the request is actually forwarded to the microservice, to the backend application, you validate the token, and if it's okay, send on the request. If it's not, then you block the request. Talking about tokens, it depends on how many issuers you have, but there are companies which have quite a lot of issuers, and if you have, well, then basically what happens is that the applications, they need to know all these issuers. They need to understand the format of all these tokens. Now, the format, the technical format, usually is standardized, being a JSON web token, but that's only how it's built up. Like, it's a JSON structure. And there are some claims which are in that token by standard, like the sub, etc. But other claims, like role information, sometimes it's called groups, sometimes it's called roles, etc. So the applications would need to understand all of that and map all that. But being here, you could implement very easily a token exchange function and then have one single token kind of distributed to all these applications. So they can standardize on an internal token. There are other options, like you could do filtering here, OWASP top 10 protection, ICAP filtering, virus protection, virus scanning, etc., etc. And you can do logging, metrics, tracing information, what is requesting what, etc. You can do all that. So if this functionality is really interesting to you, talk to me, because that's something we do, that's what we do, and that's why I felt qualified to give this talk today, because we build a product around all of that. Okay, but I think it's time for an apéro now, unless you have some questions. Okay? Have fun with the apéro.